Alright guys, welcome to lesson 7.3. We're going to do something called particle motion problems today, mainly focusing on distance and displacement. We've done particle motion before. We're just going to be adding stuff to it that pertains to the kinds of integral topics that we've been learning about. So first of all, let's go ahead and review some basic concepts here. So if I were to tell you that S represents position, in other words, if you were to plug in some given time to this function here, the output would tell you where the object is located, then S prime is equal to velocity, which we can call v of t, and that will tell you the velocity of the object at a given time. And if you take the derivative of the velocity, that tells you acceleration. Something else that we've discussed is how when you have a positive acceleration, that means your velocity is increasing. That either means it's positive and it's becoming more positive, or it is negative and becoming less negative. Because if you have a negative number and it's becoming less negative, that's actually increasing. A negative acceleration means that your velocity is decreasing, which means that either it's positive and decreasing, or it's negative and becoming more negative. Okay, so just some basic concepts there to review. Let's go ahead and go on a little bit further. We've also talked about how when velocity and acceleration are both positive, your object will speed up. Or if they're both negative, it will speed up. But if they're opposite signs, your object will slow down. And the way that I described it back when we learned this the first time is acceleration is kind of like a pull. And so long as the pull is moving in the same direction as your motion, then you're going to go faster. But if the pull is going in a direction opposite from your direction, you'll slow down. So let's go ahead and review some concepts here. I've given you guys a graph over here at the right of the velocity of an object. So for instance, at t equals 3, the velocity is 3. And we don't have any units here, so I can't say meters per second or anything like that. But at time equals 3, the velocity is 3. Or at t equals 9, the velocity is negative 9. Another factor to keep in mind is that we're talking about an object moving along a y-axis. So in that case, a positive velocity would mean it's moving up, and a negative velocity would mean it's moving down. Remember, velocity tells you direction, right? All right, so when is the acceleration positive? Acceleration is positive when v prime is positive, because v prime is the acceleration, and v prime is positive anytime our graph has a positive slope. All right, so anywhere where this graph over here would have a positive slope, that would be a place where the derivative of v is positive, which would mean the acceleration of the object is positive. So right there on the interval from 0 to 3 would be our final answer for that one. All right, let's go ahead and move on to our next question then. When is the acceleration negative? Well, as you guys can imagine, that's going to be the opposite, right? So anytime v prime is acceleration is negative, anytime v prime is negative. V prime is negative anytime the slope of this graph is negative, and that would be here. So that's from 5 to 9. Now, here's the next question. When is the object speeding up? So to answer that, we actually need to know something other than what we already have. We need to know, I'm going to add these questions up here. When is v prime positive? I'm sorry, when is v positive? We already know when acceleration is positive and negative, but we also need to know when velocity is positive. Well, velocity is greater than 0 when the graph is above the x-axis. Okay, so for instance, use a different color here. V is positive anytime we're above the x-axis, so that would be all of this. Now that we know that, then it's not too hard for you guys to kind of realize that over here, since the graph is below the x-axis, that's where v is less than 0. So now we know where acceleration is positive and negative, and we also know where velocity is positive and negative. Now this question is asking us, when is the object speeding up? Well, the object is speeding up when velocity and acceleration are both positive or negative. Okay, they're both positive on what interval? So let's find that first. Well, the red area is where velocity is positive, and the purple area is where acceleration is positive. So right here, they're both positive. And so since velocity and acceleration are both positive on that interval, then we would say the interval from 0 to 3 is a place where they are both positive. But we're also speeding up on the interval where they're both negative. Now, the green line tells me where the acceleration is negative, and the orange line tells me where the velocity is negative. So in this case, they're both negative here. And so that would be from 6 to 9. So those are the intervals where it's speeding up, which would mean all of the other intervals are either slowing down or not changing at all. So we have our answer there. Let me clean this up a little bit. All right, so we have from 1 to 3. I'm sorry, I don't know why I keep doing that. 0 to 3 and 6 to 9. And if you were ever asked to explain why, you would say because velocity and acceleration have the same sign. Okay, now I'm going to erase my explanation because of space, but it might be a good thing for you guys to include in your notes. Okay, all right, let's go ahead and move on to our next one here. When are they slowing down? Well, the object is slowing down when velocity and acceleration have opposite signs. Where does that happen? Right here is the only place that happens. The red indicates that my velocity is positive. My velocity is positive because the line is above the x-axis. But my acceleration is negative because the slope of that line is negative. And the slope of that line is the acceleration. So in that case, we have a positive velocity and a negative acceleration. So this happens on the interval 5 to 6. Since v is greater than 0, but acceleration is less than 0. Okay? Now once again, it's probably good for you guys to have the explanation on your notes, just in case you have an FRQ and you're asked to explain it, but for me I have to erase to make space. When is the object moving up the y-axis? The object is moving up the y-axis when v, the velocity, is greater than 0. A positive velocity means you're going up. A negative velocity means you're going down. Now, if you're on a horizontal axis, then positive means you're going to the right and negative means you're going left. But remember, we are moving on the y-axis here. So the object is moving up anytime the velocity is greater than 0, which is this region up here, which we've already highlighted in red. It goes from 0 to 6. And I wonder if I'll just ask the opposite question now. When is it moving down the y-axis? You guys should be able to answer that now. That would be any time the velocity is negative, and that would be from 6 to 9. The orange section. All right, so I want to talk to you about two concepts, distance and displacement, and hopefully you'll see at the end what each one of them is, what they have in common, and what is different about them. So let's introduce the raw definitions first. Let's say that there's a guy, and he starts right here at this point, -3. And he decides to go for a little walk until he gets to 4. But he's not happy there, so he decides he's going to go back and stop at 1 now. So now he's done for sure. Okay? Well, what distance did this guy travel? Basically, to find that, we would have to take the sum of all lengths. So his first distance that he traveled, he went from -3 to 7. I'm sorry, -3 to 4, which is a total of 7. And then his next distance that he went 3. And so altogether his distance was 10. Okay? So that's the total amount of distance this guy traveled. Now let's go ahead and talk about displacement. Displacement is basically how far away the ending point is from the starting point. All right, so if he stops right here and he started here, how far apart are those two numbers, -3 to 1? Well, that's 4. It's 4. All right, but believe it or not, so even though those things seem like two very different concepts, they actually have something very much in common. They both involve the concept of 7 and 3. The distance to the right and the distance to the left being added together. But this one is 7 plus 3 and this one is 7 minus 3. So how's that work? Well, the reason why we have a positive 7 is because we're moving to the right. So we have a positive 7. But why is it a -3? Because we're moving backwards. We're moving to the left. So instead of a positive 3, I'm going to put a -3 here. So when you do a 7 plus a -3, you get 4. But distance is not 7 plus -3, but rather it's the absolute value of both of these things. the absolute value of 7 plus the absolute value of 3. Because, in other words, distance doesn't really care about direction. It just cares about how far you went. So, yes, we went 3 spaces to the left, but I really don't care that it's to the left. I just care that it was a total distance of 3. So by taking the absolute value, it ignores the direction, and it becomes this equation instead. So here's what they have in common. They both involve the addition of the distances or the lengths that were traveled, and they both include the signs. But the only difference is the distance will get rid of the signs by taking the absolute value. The result here tells you the total length that was traveled. The result here tells you how far the end point is away from the starting point. Now, just as an extra little tidbit here, let's say that we never move left. Let's just say this guy never moved left, and he just went from -3 to 4. In that case, your distance and displacement would be the same because you only have positive distance. You know, your distance would be a total of 7, and your displacement would be a total of 7 because the displacement and you never have to add a negative or anything. It's always positive. So that as soon as if there's no negative values, then displacement becomes the same thing as distance. All right, so that's what distance and displacement are. Now, how do we find distance and displacement in calculus? Well, as you guys know, distance equals speed times time. Well, velocity is kind of like speed, but it also has direction. But if you take the absolute value of your velocity, then it becomes the speed. And if we multiply that by time, and then add together all the velocities from the starting point to the end point as they're being multiplied by time, then you're going to get the total distance. So this little formula right here is how you find the distance. But if you want to find the displacement, you just do the same thing. It's just that it doesn't have an absolute value on it because we don't care about we actually do care about the directions. And what this tells you is this is a net change formula, right? And the reason for that is because V, isn't that equal to S prime? And when you integrate a derivative on a interval, then that gives you a net change of S, which is your position. So in other words, if you integrate the velocity, it tells you how far your object is from its original location. Now, if your displacement comes out positive, then that means that your object it tells you not only how far, but it also tells you whether it's to the right or above, left or below the starting point. Okay? If it's positive, that means that where it stopped is either to the right or above it, depending on whether you're moving on a horizontal or vertical axis. Or if it's negative, that would mean that it's either to the left or below, depending on whether you're moving on a horizontal or vertical axis. But distance, we don't really care about direction at all. We're just totally finding the total length. And so it ignores the signs, and because of the absolute value, it just tells us how far the object went. All right? And so that's how we find distance and displacement in calculus. Okay? So consider having a particle moving along a horizontal axis, and sometimes it's moving really fast, sometimes it's moving really slow, sometimes it's moving really fast and sometimes slow, and you wanted to find the total distance traveled. Well, you could integrate all the velocities over time with the absolute value to find the distance, or you could just integrate all the velocities over time without the absolute value to find out where the object stops, so to speak. So we could take our net change formula that we learned before. As you guys remember, we learned this thing here, right? F of x is equal to f of a plus the integral. These formulas are identical, just we're talking about different concepts. Here, my function is the position function. So this would be my ending point, and this would be my starting point. V of t is the derivative of s, just like f prime is the derivative of f. So when we integrate it from a to s, that's going to tell me my displacement, which Before, when we're talking about other kinds of problems, we called it net change. So it's really the same formula. It's just that we're applying it to a specific type of problem now that has to do with distance and speed instead of just any kind of thing like we were doing all kinds of problems before. But in this case, when you're talking about just distance and speed, then you think of it with these kinds of variables instead. All right, so let's go ahead and jump into what we're working on today. I've given you guys a velocity graph over here at the right. It's a move. You want to pay attention to what axis you're moving along. We're moving along the y-axis. I also tell you the starting point at t equals 0, its position is 4. And now for question 1, I'm asking you guys to find the displacement of the particle. Now remember, what does that mean? I'm finding how far away from its starting point is it when it's done moving. Okay? So by the time it gets to time equals 9, how far away is the object from its original location? And its original location was at 4 along the y-axis. Okay? So, how do you find displacement? Displacement is the integral of the velocity on the interval that you care about. Since I want to go up to time 9, we're starting at 0 and we're ending at 9. Right? And so this would be my displacement from 0 to 9. Now, in this case, we're going to solve this with geometry, because all of these are just straight lines that we could just do some basic geometry with. So I've got a triangle here, and a triangle here. So let's go ahead and calculate all these. So this is 4.5. This is 6. This is 1.5. And this one is 9 times 3 is 27, cut in half is 13.5, but it's negative because it's below the x-axis. All right, so the integral of our function from 0 to 9 is basically just all these areas added together. All right, so what would that be? Negative 1.5. Now I want to interpret this. This means that the particle is 1.5 units below, because we're on a y-axis. If it was an x-axis, we would say to the left. But since it's a y-axis, we're going to say below. And it's below because it's negative. 1.5 units below the starting point. That's what that means, because this is displacement. So when you integrate your velocity, that tells you the net change in position. We did the integration using geometry, and we got negative 1.5, which tells us that our position is 1.5 less than the starting point. In other words, 1.5 spaces below the starting point, because we are on a vertical axis. All right, let's go ahead and take a look at another one here. Find S of 9. Find the actual position. Well, we know that the position of the particle is equal to its starting point plus its displacement from 0 to 9. So my starting point, well actually before I put 0 to 9 in there, let me back up a little bit. Starting point A, ending point X. Now I want to find out what's S of 9. My starting point is 0. So we're going from 0 to 9. We've already done this. It was negative 1.5. What is S of 0? My starting place was 4. Now we already know that my object is supposed to be 1.5 units below the starting point, so what is that? Well, that would be 2.5. And there you go. And that just tells you how far it was. The object, we're on a vertical axis. You don't need to draw this, but just for teaching purposes, I'll show you. At t equals 0, my object had a position of 4 along the y-axis. But at t equals 9, now it's at position 2.5. So the object went from a height of 4 to a height of 2.5. So it dropped overall by 1.5 spaces. Now it actually did a lot of things. It probably went up and then down to get there, but the net change in position was it went from 4 to 2.5. So because it decreased by that much. All right, let's take a look at another question here. Find the distance. Distance is the same thing as displacement with one caveat. You're taking the absolute value. And so we're still going to add together all these shapes here, 4.5, 6, 1.5, and negative 13.5. But the difference is they're all going to be positive now, because what this means here is on this interval, the object moved up the y-axis by 4.5 spaces. And then on this interval, it moved 6 more spaces up the y-axis. And then on this interval, it moved 1.5 spaces up the x-axis, y-axis, I mean. And then on this interval, it moved 13.5 down the y-axis. But we don't really care about what direction. I just want the distance. So I guess what we could do is put that one like that in brackets, just so we remember that we're taking the absolute value of it. Why don't we do that to all of them? But either way, when you add all these up, what do you end up with? You end up with 25.5, I believe. So the total distance traveled by this object is 25.5 units. So it went up 12 spaces, and then it went down 13.5 spaces. That's a total of 25.5 spaces traveled overall, and that's the total distance that the object traveled. Okay, so we got a couple more questions here, but before I get to those, I would like you guys to try to do some similar stuff. So for now, I just want you guys to focus on homework problem number 1, and I'd like you guys to do A, B, and C. And pause the video here. When you unpause it, I will have the solutions up for you to check your work. All right, so there you go. Number 1 is negative 6.5. Number 2 is negative 14.5. Number 3 is 17.5. If you need to look at it a little bit longer, feel free to pause the video to do so. All right, so I'm going to be answering numbers 4, 5, and 6 all together because you really answered them in the same exact way. Notice they're all asking something similar. They're all asking, when is the object farthest away or farthest down or farthest up? They're asking for the most value of something, right? And when you ask for the most of something, what they're really asking for then is a minimum or a maximum, right? And so this is a absolute min or absolute max. So all of these are critical. These are all candidates tests questions. Now I think I'm going to start with 5 and 6, and then I'll get to 4 after that. So let's start with numbers 5 and 6. So when you're doing the candidates test, my input variable is time, and we're talking about the position S, and we want to know when is the position greatest and when is it least. When it's greatest, that tells you when it's highest up the x-axis, and when the position is least, that tells you when it's lowest on the y-axis. And by the way, this is a typo. That should say y-axis, not x-axis. Okay? Have you ever found that you can't cross an X out? It's very frustrating. All right. Here we go. So let's do it. So what we need to do is we need to first of all find the endpoints. My endpoints are 0 and 9. Next, I need to find where the critical values of S are. In other words, I need to find where S prime equals 0. Now, as you guys know, the function S is given by this. Now in this case, we already know s of 0. It's, I think it was 4, if I'm not mistaken. Now if you wanted to find the derivative of s prime is going to be, the 4 goes away because it's just a constant. And according to the second fundamental theorem of calculus, when you take the derivative of this, the integral goes away and the x drops down in the place of the t, and we have this. So s prime of x equals v of x, which we already knew that anyway, right? So if I'm asking when does s prime equal 0, that's the same thing as asking when does v equal 0. In other words, where does it touch the x-axis? Because this is the graph of v, and when it touches the x-axis, that's when it equals 0. We've already got this point, but there's another one over here, and that's at 6. And so that's my critical value. So how can you find the critical values of a derivative using a derivative graph? Well, once again, you just look for where it touches the x values. We've done that before many times. I'm just showing you in the new context here. So critical values are where critical values of s are where the derivative of s, which is v, equals 0. And when v equals 0, it's where it touches the x-axis. All right. So now I need to find what is my position at 0. I need to find what is my position at 6. And I also need to find what is my position at 9. Now they told us what the position at 0 was. They told us it was 4. And in case you guys forgot, on the second part of example 1, we found s of 9. S of 9 was 2.5. So that one's also done. So the only other thing I need to do now is I need to find s of 6. Okay? So let's go ahead and let's find s of 6. All right. So s of 6 is going to be my starting point plus my net change in position from 0 to 6, or also known as my displacement, right? So s of 6, this is 4, and we can do this using geometry. What is the integral of v from 0 to 6? So that's 4.5, that's 6, and that was 1.5. So altogether, you're looking at 12. So initial position was 4. The displacement changes my position by adding 12 more to it, and therefore my position at 6 is 16. All right, and so now we're ready to answer these 3 questions. All right, so let's start off with number 5. When is the object at its highest point on the y-axis? Well, that would be at t equals 6. At t equals 6, we're at a height of 16 units up the y-axis. When is the object at its lowest point on the y-axis? That would be at t equals 9, because that's the lowest number for the output there of my position. Now the next question says, when is the object furthest from its starting point? Now that's a different question, but we don't really have that much more work to do here to find the answer to it. Let me show you why. What was my starting point? My starting point was 4. So all we have to do is find out how far each one of these points are away, these distances are, or points are away from the original point, and we're good. So how far is 4 away from 4? Well, there's no space between them at all. There's 0. How far is 16 away from 4? 12. So it seems like at s equals 6, the object is now 12 spaces away from its starting point. How far is 4 away from 2.5? Well, that's about 1.5 spaces away. So when is the object farthest from the starting point? Basically, just take your answers that you got for s and subtract them all from the starting point, and you're going to have your answer. Which one of these is the greatest value? The one that has the greatest absolute value, or the greatest distance from 4, and that would be at t equals 6. Okay? So that's how you handle the minimum maximum questions for these types of problems. You're just going to do your candidates test. Number 4 is a special case where you find the starting point and subtract from it, though the minimum maximum points to find the distances instead. All right, so you guys, of course, are going to get to do one of these. So go ahead and pause the video here and do numbers D or letters D through F. And when you're done, you can unpause the video and you'll see the solutions. All right, so here are the answers. First of all, you'll notice that we have my starting points, 0 and 10. And we have two critical values, 1 and 7, because it touches the x-axis in two places. Remember, critical values of s are where s prime equals 0. S prime is velocity. This is a graph of velocity. So velocity, when velocity equals 0, that's when s prime equals 0, which is a critical value. And the velocity equals 0 when it touches the x-axis here. And so that's at 1 and 7. Next, we're going to find the position of this particle at each of these candidates. So at the left endpoint, we have -8. At the right endpoint, we have -14.5. And at each of the candidates, we have -7 and -19. And then color-coded here, I've got the answers. So at t equals 1, this should be a positive 1, sorry, not a -1. At t equals 1, we are at our point furthest to the right. -7 is the number that is farthest to the right because it's the least negative number up there. At t equals 7, we're at the farthest to the left because that's the most negative number. And when are we farthest away from the starting point? So we just take each of these numbers here and subtract them from -8, the starting point, and you can find the distance they are away from the starting point. The one that's greatest is the 11. And so at t equals 7, we are at the greatest distance away from our starting point. All right, and so that is part 1 of what we're looking at today. Let's move on to a second example. So we're going to be doing example 2 on our calculator here. You could do it by hand, but it's a little bit tedious, honestly. For each problem below, v represents the velocity of a particle at time t, and s of t represents the position of the particle at time t. The object is moving along a y-axis. All right, so we want to find distance. Well, we already know how to find distance on the interval from 0 to 10 is by taking the integral of the absolute value of the velocity and we're done. It's that simple. And we can just do that on our calculator. So let's do that on our calculator. So the first thing that we're going to do is we're going to, of course, turn our calculator on. Then we're going to go to y equals, and you're going to type in your function, which as you guys can see I've already done here, x squared minus 9x plus 14. That's my velocity function. Once you're done with that, you can come on out of here. And we want to enter this little formula that we've got over here. So you're going to push math. You're going to push 9 to bring up the integral. You're going to type 0 to 10 for your limits. And then you're going to type in the absolute value of velocity. So how do we get absolute value again? You push math. You're going to scroll over to where it says num. And then you're going to click 1 for abs. And that's absolute value. And then you're just going to type the function in there, which we've got stored under y1. So I'm going to put vars, scroll over to y vars, select function, select y1, and it's in there, and then x. Enter, and absolute values always make your calculator think a little harder than usual, so they take a while to load. You can see the little marks moving in the corner there to indicate that it's thinking. And if we rounded this to the thousands place, that's just going to bump everything up to 65. And so our answer for that is going to be 65. So the total distance traveled by this particle is 65. Okay, now we want to find the displacement. Displacement is the same thing as distance, it's just that there's no absolute value. And it tells you something different too. It doesn't tell you just how far the object traveled, it tells you how far the object's ending point is away from its starting point. So let's go ahead and calculate that. We're going to do the same thing, so I'm just going to push second and then entry, and it brings back the entire thing. It's just that I'm going to scroll back into here and I'm going to push delete once to get rid of the y1 and delete twice to get rid of the absolute value, because we don't want absolute value for displacement, we just want y1. So now I'm going to put the y1 in there. That second entry can be very helpful. Save you some time of having to retype things over and over again. So it's the same exact problem, just no absolute value. Push enter. Let's see what we get. Now I've got 23.3 with a bar on top. And since it's positive, what that means is, and we're moving along the y-axis, that means my starting point is at 4. After the 10 units of time have gone by, the object is now 23 spaces above 4 at that point, or 23.3 spaces above the 4 at that point. So now we want to actually find the coordinate of the particle at that time. Well, the coordinate, in other words, s of 10, the position of the particle at that time, is equal to the object's starting time, or starting position, I mean, plus its displacement over that interval. And we've already calculated this. We just got that to be 23.3 with a bar on top. And they tell us this, s of 0 equals 4. And so adding those together is 27.3. So that's the first 3 questions there. Now we're going to go ahead and we're going to do the other question that we do often, which is finding the highest point and the lowest point. So once again, what they're asking us to find is the positions of this object, right? And when is the position highest and when is the position lowest on the y-axis? Well, we already know that we're going from 0 to 10, so those are my endpoints. I only want to go from 0 to 10. But we also need our critical values. I need to know, where does s prime equal 0? Well, s prime is equal to v. So I really want to know, when does v equal 0? Now there's 2 ways you could do this. You could do it by hand by setting your velocity function equal to 0 and solving. This one actually will factor, just so you know, so you could do this one by hand. But I want you guys to know how to do it on a calculator. So today I'm going to show you guys how to solve these on a calculator. Another way to do it is, instead of setting it equal 0 and solving, you can just ask yourself, where does it touch the x-axis? And by the way, you could solve every quadratic this way. You could just graph the quadratic, and after you graph it, find where it touches the x-axis, and that will tell you where it equals 0. Okay, so I know some of you guys struggle with your factoring, and quadratic formula is pretty tedious. This is another way to find where it equals 0. So just graph it and find where it touches the x-axis. So let's do that. Now I've already got my equation entered, so all I need to do is push graph, and that'll graph it for me. Once again, you're going to want to make sure that your viewing window includes the interval that we're looking at. I'm going from 0 to 10, and it has 0 to 10 on here already, so we're good. But you can always click window and adjust it if you need to. But in this case, we're fine. So I want to know, where is it touching the x-axis? What are these 2 points? Now, in this case, they are what they look like. But I want you guys to know how to do this, because sometimes they cross at really weird points that are decimals, and you need to know how to get those values using your calculator. So, time to learn a new thing. How do you find where it touches the x-axis? You're going to push the following buttons. You're going to push second. You're going to push Calc. And you're going to choose the option that says 0. And that's just a math word for where it touches the x-axis. Now, it says left bound. So let's say right now that I want to find this point. I want to know what's the x value for that point right there. What I'm going to do is I'm going to scroll with my cursor until I get there. Now, you could, like right now, I can't see my cursor. Can you guys see the cursor? I can't. If you want to know where it is, it tells you right here. It's at x equals 0.2127 and y is 12. So it's way up here. It's off the screen. But if you start scrolling to the right, you'll eventually start seeing it come off there. Now, it says left bound right here, you'll notice. And what that means is we want to create a boundary point to the left of this point that we want. So I just need to get my cursor to be just to the left of that, and then I'm going to push enter. It doesn't matter how far left of it is really, but just pick a point to the left of that root. Now after you click enter, it puts a little arrow there. It's like a marker saying, cool, we're going to put a marker here. And now it says, where's your right bound? So you're going to keep scrolling till your cursor is to the right of that root, and then you push enter again, and it puts a new marker. And what that does basically is it's telling your calculator, look for the place where this graph touches the x-axis in between here. In other words, that point. So the last thing it says is guess, and you just say yes please by pushing enter, and it will give you the answer. And the answer is x equals 2 and y equals 0. Now sometimes when you're doing these problems, this won't say 0. It'll say something like 0.000001 or 0.95 e to the negative 12th. That basically just means 0, just so you know. It's just that the calculator is rounding it to a weird value, but it's 0. It's fine. So one of our critical values then is 2. Let's find the other critical value. This is a good time for you guys to try to do this exercise on your own. See if you guys can find this root. Remember, you're going to push second math, 0, pick a point to the left, pick a point to the right, take your guess and see what you get. Pause the video if you don't want to watch me do it. You want to try it on your own. But I am going to start doing it myself right now. And that one is at 7. And don't be surprised, you guys, if you end up with weird decimal answers. That's usually what's going to happen. Okay? All right. Now, let's go ahead and find all these values here. So I need to find s of 0, which we already know. F sub 0 is 4. I think I'm going to use my whiteboard. It's hard to use my mouse. F of 0 is 4. And then we want to find s of 2. We want to find s of 7. And we want to find s of 10. Now, I believe we already found s of 10. That was the number 3. That was 27.3, right? Let's go ahead and see if we can find s of 7 now. So how do we do that? Well, you need your position function. My position function is s of x is equal to my starting point, which is 4, plus my net change, or my displacement. Okay? So if you wanted to find, for instance, s of 2, then you would be plugging 2 in here like this. And once again, we're just going to let our calculator do that work for us. So I'm going to type this function here into my calculator. So let's get out of here. Second, quit. I'm going to push 4 plus my integral. So I'm going to push math 9, 0, 2, and then we're going to put our function in there, which is stored under y1 dx. So at s of 2, we have a position of 16.6 with a bar on it. Now to do the next one, s of 7, it's the same exact equation, so I'm just going to push second entry to bring back the entire equation again. The only thing that's changing is what I'm plugging into the top here, which in this case would be 7. And so that's negative 4.16 with a bar on top. And now we're ready to answer our question here for the last two. What's the highest point? When is the object at its highest point? That happens at t equals 10. When is the object at its lowest point? That happens at t equals 7. All right. So same thing, we're just doing all the work on our calculator. The hardest part is doing the highest and lowest points. Remember, you're going to graph it. You're going to find where it touches the x-axis, and then you just do your candidates test from there. All right. So here's one for you guys. Go ahead and pause the video, and when you unpause it, you will see the solutions. All right, so here's the answers to the first two, the distance and the displacement. Now, before I give you the answers to parts C through E, I want you guys to notice something here. This is not a 0. Okay, that's a 1. And the significance of that is that whenever you set up your position function, you're going to have S of 1 here, which means that whenever you have your integral here, your starting point is 1 in x. You don't put a 0 down here for your position function. It's a subtle detail, but you got to watch out for that. I assume a lot of you guys put 0 there, so I'm telling you now, so if you want to go back and correct it. So here will be your position function. S of x is equal to 3, and it's 3 because it's S of 1. And since we're starting at 1, then your integral also has to start at 1. So there you go. So that's your position function. So if you got that wrong, you might want to go back and double check your work. You'll still have the same correct answer for where it touched the x-axis. That won't change, but your y values will all be a little bit off if you don't have the correct integral value down here, right? So let me bring up the solution now. All right, so here's my candidates test and my answers. So the answers are 2, 2, and 4.562. The starting point is 0, ending point is 5. The places where your graph would have touched the x-axis, which tells you where we have our critical values, are those 3 values there. Notice I called them A, B, and C because I used my store feature on my calculator, which I talked about in a previous lesson. That way I didn't have to round it on my actual calculator, even though I round it here when I write it. And then plugging it into my position function, which I gave to you guys a little bit earlier, goes here. Now, I'm concerned some of you guys might have gotten S of 0 equals 3 here, but remember, since this is S of 1 actually, S of 1 is 3. So S of 0 will be different, and you have to use your position function to get it by plugging 0 in here. But anyway, the point that is farthest to the right would be, or the point in time that's farthest to the right would be here, so that's at t equals 2. And the time when it's farthest to the left is here, and that's at t equals 4.562. And the time when it's farthest away from the origin, in other words, it's farthest away from 0, is also right here at 4. So that would do it. All right, and so that's the end of our lesson. And happy homework reading, and we'll see you guys in class.